And of course, I did all of that. Sorry, I just turned my recording on, so the first part of you didn't see my announcements. So let me just go back here real fast. Right. So I talked about this. I talked about the exam, 18 question, 2 hours. Right. The question format may not be exactly like a quiz, so don't necessarily think that's the way the exam's going to be. I don't think it's any harder than the other exams per se. Please check your grades on questrom tools. And again, let me know any discrepancies. Please do it now. Don't do it over the weekend because grades are going to be done by then. By the way, I probably will not post grades probably till Monday. Okay. I mean, I'll probably have your grades done Thursday, Friday, but I always, I do them, then I kind of think about them, go back, look at them, make sure I don't have to tweak them a little bit type of stuff. And then we go from there. Again, generally speaking, your grade is not necessarily, the final grade is not rounded or not scaled, right? We scale the individual exams. So we don't scale exams and then scale the final grades. That's too many scales, right? So again, the first 2 exams everybody's done really well. So it has been no scale. I don't think there's going to be one for this test as well. So I think kind of where you are. Now, again, obviously, if you're concerned about your grade, certainly email me. We can have a chat. If for some reason you need a grade to maintain a scholarship, that's really a conversation I can't have, right? I can't. If you need a B+ to maintain a scholarship, then it was your responsibility to maintain a B+. If your grade's coming out to a B-, I can't bump you up to a B+ just to keep your scholarships active. That's an unfair request of me. Okay. And again, the last slide was we talked about what's happening today, right? Again, I'm going to post some practice quizzes and practice KPOD at the end of class today. And we'll see what we do. Again, we'll have a discussion later today if people want to talk about returning to BU. Okay, so sorry, the recording's back on now, so everybody should be up to date. Okay, so let's do my document camera and do the problems for today. I'll stop sharing. There we go. Okay, 1 second here. Got to rearrange my There we go. Dimitro, you got a haircut? Did you get a haircut, Dimitro? Yeah, I can see it. Because you were the last person that spoke to me, so so I've got a screen of everybody's thumbnails, and then I've got the person that last spoke is the person that's on my screen, so that's you. Okay. Let me get my pens here. Sip of coffee, and away we go. All right, when entering California, vehicles are inspected to ensure there is no fruit being brought into the state. Full inspection is done on a random basis. Suppose that one entry point has 5 right lanes, so that's your N. The manager wants the same number of inspections in each lane, same number. So it wants a uniform distribution, right? So data was collected. So what we have the 5 lanes, and these are the distributions. This is clearly your observed. Okay. All right. So we want to, is there evidence at alpha 0.05? All right. is not, whether it is not uniform. Okay. So our HO and H1. Again, we know, remember, you know, you got a hint today. This is goodness of fit. But remember, on an exam tomorrow, it's not going to tell you this goodness of fit. So you've got to make sure to understand whether this is goodness of fit or test of independence. Okay, so it's goodness of fit because you want to know whether it falls to uniform distribution. It doesn't ask you about whether the variables are independent. So data fits model. Data does not fit model. Reject HO if chi-square calc, right, is greater than some number, right? So we have this here, right? Our n is 5, so our degrees of freedom are 4, which is k minus n. So it's 4, right? Alpha 0.05. So I make this larger here, right? So 0.05, 4 degrees of freedom, it's 9.49. So reject HO if it's greater than 949. Okay? So this is step 1, step 2, step 3 is our chi-square calc, right? And that is observed minus expected squared all over expected and the sum of all of them, okay? So we have to come up with our expecteds. So basically we have to add these all together and we get 2120. We have to divide that by 5 for a uniform distribution and we get 424. Right, these are our expecteds, okay? So therefore we just do it out. So therefore it's these two first, 380 minus 424 squared all over 424, plus the other next one is gonna be 403 minus 424 squared all over 424 plus blah. I'm not gonna do this all 5 times. So you do this all together, and when you add that all up, you should find a value, I think, of 72.2. Okay? So therefore, your step 4, clearly, it looks like this. This is 0.05. This is 949. 72.2 is, you know, all the way out here. So clearly, you're going to reject HO, not a uniform distribution. Doesn't ask you, but let's do p-value. P-value is chi-dist, right? The cutoff, 72.2 degrees of freedom, 4. Chi-dist is definitely fair game for the exam tomorrow, just like t-dist. I can definitely ask you to find out p-value in the 3 different ways. P-value using the means, using the z table, p-value using the t-distribution, meaning the t-dist command, or the chi-square table, meaning the chi-dist command.
Professor.
Yes.
So what does the p-value mean in this question?
P-value is still the same thing. I mean, it's basically a sense of how sure you are, right? Because 72 is so far away from 9.49. It basically tells you how sure you are. Are we sure this is not a distribution? Hell, I'm very sure this is not a uniform distribution, right? Okay. See, the problem is people sometimes look at p-value and they look at these numbers and they say, oh, 72 is really far away from 9.49. Well, that's true, but remember, you're not really looking at it. You're not really looking at it as a number, right? You're really looking at it. You're looking at it as area, right? So here's 94. Here's 9.49, right? So this is here, right?
That's like the tail, right?
Right, the tail. So if this is 5%, Well, the thing is, you can't really, let's say our critical value, was really 10.1. Well, 10.1 may be here, right? And you say, oh, 10.1 is not near 9.49. That's not close. Well, it is close because really you're looking at area. So if all of this is 0.05, this area here may be 0.498. 0498. So actually looking at the size of the area, it's really close, right? So that's why you're really looking at p-value in terms of the area on the curve, not just, you're not looking at stuff along a number line.
So like
make sense?
yeah. So like, what would like a high p-value mean?
A high p-value mean?
No, like what would that mean? Like if the p-value is high, if
if the p-value was 0.05?
no, if it's high. Like,
if it's high, it'd be on this side. You'd accept HO. Again, you always look at p-value versus alpha, right?
yeah.
So that's really what it means, right? This is a very simple accept or reject HO. But if you want to know the intricacies of, in this case, finding out that value, you're looking at alpha, in this case is 0.05. The p-value for the chi-dist of 72 with 4 degrees of freedom is probably 0.001 something, right? So again, now 0.01 is not anywhere near 0.05.
Okay.
Right? It's really a measure of understanding area. And you understand that it's different because you're looking at area under the curve. You can't just look at the numbers, right? That's kind of a subtlety.
Okay.
That's great. Good question. Any other questions? All right, let's do the next one. The owner of Bob's Gas believes his customers pay equally between debit, credit, and cash. To test his model, he selects a sample of things. So obviously these are the observed, right? Okay. Now we could do the expecteds right now. Now it's gonna be pretty simple, right? Because it says he thinks they pay equally, right? So again, that's also a uniform distribution. So 110, 120, and 70 is a total of 300. So if I have 300 and I make it equally, it's going to be 100, right? So this is going to be your expecteds right here, right? So observed, and expected. So HO and H1. Data follows model. Data does not follow model. Step 2 is reject HO. If chi-square calc, right? This is chi-square, right? This is chi, this is x. Don't, you're not going to write this, obviously, on the exam. If you wrote this on the exam with the computer, that'd be fine. But if you're actually writing it out, remember, it's chi with that thing versus x, because x squared in statistics is really something else. Okay, greater than some number. Again, how many categories? We have 3. So 3 minus 1, k minus 1, it's going to equal 2, right? So again, going our handy dandy chi-square chart. And again, I say again, make sure you probably want to print out or have this available to you. Again, you can have it on your computer. Just want to make sure you can get it quickly, right? So 0.05, 2 degrees of freedom, it's 5.99. So 5.99, right? Then do your chi-square calc, right? So you get 110 minus 100 squared all over 100 plus 120 minus 100 squared all over 100 plus 70 minus 100 squared all over 100. 110 minus 100 is 10. 10 squared is 100. Over 100 is 1. 120 minus 100 is 20. 20 squared is 400. Divided by 100 is 4. 70 minus 100 is negative 30, but when you square it, that becomes 900 divided by 100 is 9. So therefore, your answer is 14 for your chi-square calc. Okay, we're looking versus 5.99. 5.99, 14 is clearly here. Again, reject HO, not even distribution between credit, cash, and debit at Bob's gas station. Okay, that's it for those two problems in that thing. I do want to screen share with you something else. Okay, as I mentioned, the Parker problems, right? Chi-square units with fit practice. Right? Right. So here, this is a little more of a difficult problem. Okay, so this may be going to do. This one here, this is a great problem, right? Mrs. Miller, a very popular baker whose delicious pies are known for county to county. She's getting ready to bake 100 pies for local holiday charity. She tells her assistant Billy to go buy fruit for the pies. Do not worry about being exact, Billy. I will need about as many apples as peaches, but only half as many pears, and only about half of that as many bananas and bags of cherries. Whoa, right? So again, I do not want students to think that just because you've done a homework problem that's pretty easy, that a question on the exam is going to be very easy. Okay, so again, homework problems are meant to be a basic initial foray into the topic. You then need to study it to make sure you understand the subtleties so you can do it. Okay, so this question M is a good problem. Okay. Any questions on this topic? Okay, so then let's go right to the next one. We're chugging right along here. Let's do a couple of problems for. As I mentioned, we didn't do 122. Again, that 122 is a good problem that we skipped today. Has to do with looking at the Poisson distribution and the binomial distribution as far as the goodness of fit. Again, it's not going to be on a test tomorrow, and I didn't want to take a lot of time. You know, that 122 takes a lot of time to do. That problem alone takes a half hour to do that. And I didn't want to confuse things with what you're going on. Okay, so obviously here's something different. So the owner of a home heating oil delivery firm would like to investigate how fast bills are being paid in 3 different suburban areas. Random samples of 100 accounts are selected in each area. The number of days between delivery of the oil payment of the bill recorded is the following results, right? So area 1, between 1 and 15 days paying the bills, 34, right? So this is how you read this thing. So basically 48 people did between 16 and 30 and more than 30. Remember, these are what? These are counts. So therefore they are integers. Okay? Alpha 0.10. Is there a relationship, evidence of a relationship? So clearly this is what? Test of independence, right? Because independence is whether it's related or not related. So HO and H1. Where you live, and how quickly you pay your bill is independent. And then blah, 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 blah is not independent, right? You can just say the variables are independent, the variables are not independent. That's fine. Reject HO if chi-square calc, right, greater than something. Okay. Number of rows minus 1. So 3 minus 1 is 2. Number of columns minus 1. 3 minus 1 is also 2. Right? Multiplying together, that's 4. Okay. So 4 degrees of freedom at 10%. Keeping Ryan up. Sorry, buddy. 10%, 4 degrees of freedom, 13.
Is this supposed to be the first column?
First one, right. There it is. 7.78. Right. I did the right. 0.01, 0.10. So again, I made that mistake myself. So make sure you're looking at the right column. 7.78. So 7.78, right? Okay. So basically what you want to do is this total is 116. This total is 144. This total is 40. Grand total is 300. The column totals, this is 100, 100, and 100. Okay? So then, our expecteds, right? So again, this is still going to be 116, 144. This is still going to be 40. This is still going to be 100, 100, and 100. Okay? Now, to do this expected, it's going to be a little differently. I mean, I know that ideally I should only have to find these 4 values. I can do the rest by subtraction. But it's going to be even easier than that because they're equal to 100. So if I really find these 2 and figure out this one, the other ones are all going to be the same. So it's going to be it's going to be uniform across all different categories. It's got to be. So 116 times 100 divided by 300, this value here is roughly 38.7. Okay. Now, again, you may have something that's similar. You may not have exactly 38.7, right? So I know this is going to be 38.7 and this is going to be 38.7. 144 times 100 divided by 300, this is going to be 48. So this is going to be 48 and 48. And then what's left by subtraction, this actually ends up being like 13.3. All right. 13.3 times 3 is 39.9, but that's close enough. Again, for our purposes, we don't have to be exact. You don't have to go to all these decimal places. Okay. So there's your expected. So this is your step 1, step 2. So then you want to do your chi-square calc. Again, your chi-square calc is observed minus expected squared all over expected, but then you're going to sum them all up. All right. So observed minus expected. So 34 minus 38.7 squared all over 38.7. The next one's going to be 42, right? 42 minus 38.7 squared all over 38.7. You're going to do that 9 times. And when you do this all out, I'm pretty sure it equals 4.85. You're comparing that to 7.78. This is 0.10, 7.78, 4.85 is here, right? So your answer is accept HO, no relationship between where you live and how quickly you pay your oil bill. P-value is chi-dist. Oops. Chi-dist of 4.85 degrees of freedom 4.
I have a question, Professor.
Mhm.
Could you explain again, like why the numbers in the second table, like why they don't have to be integers?
Because you're doing an expected. It's the same reason why on an exam, if you're calculating an average for an exam, the average doesn't need to be an exact number, right? I mean, you can have an exam where the average score is 79.2, even though no one could get a 79.2.
Mm-hmm.
So the expected doesn't need to be an integer because it's expected. It's the what you expect the average to be. It doesn't have to be a real number.
Oh.
Right?
Mm-hmm.
The observed does. The expected is a calculation.
All right.
Right? So if I ever gave you this table that I'm tapping with my fingers, if I gave that table, you'd have to say, oh, that can only ever be an expected.
Okay. Okay, thank you.
You're welcome. Questions? Okay. Personnel manager at a company asked employees how they felt about their work they were doing. The following table gives a background of responses by gender. Do the data provide sufficient evidence to conclude that the level of job satisfaction related to gender? Test at alpha 1.0. Okay. HO in H1. Gender and job satisfaction are independent or not related. Gender and job satisfaction are not independent or are related. Reject HO if chi-square calc, again, this is step 1, step 2, greater than. How many rows do we have? We have 2 rows minus 1 is 1. 3 columns, 3 minus 1 is 2. Multiply them is 2. So therefore, this is our observed. This is going to be our expecteds, male, female, right? It's going to be the same distribution, meaning you're going to add these up. This is going to be 120. This is going to be 80. Grand total is 200, right? This one adds up to be 105. This one adds up to be 75, and this adds up to be 20. So 105, 75, and 20 also each equals 200, okay? So all we have to do, degrees of freedom are 2, you're going to find 2 cells. So if you find this cell and this cell, right? Obviously, if you do these 2 cells, you're not going to be able to figure it out. So you get, you know, this one, you figure it out, you got to figure out what's the total, right? So the total is going to be the exact same thing. So row total times column total divided by grand total. And again, that grand total, right, is 200, right? So 105 times 120 divided by 200 is going to be 63. Next one, 120 times 75 divided by 200. This one ends up being 45, which means this one here is going to be 12. Again, it has to equal 120. And this one here is going to be 42. This one down here is going to be 30. And this one here then has to be 8 for a total of 80, right? So these are corresponding, right? Oh, I didn't finish this other part. Sorry. So chi-square calc, right? 2 degrees of freedom, 0.10. Falling down my game here. 0.10, 2 degrees of freedom, 4.61. So your chi-square calc, like we've done before, 70 versus 65. So 70 minus 63, sorry, 63 squared all over 63. Plus the next one, 41 times 45. So 41 minus 45 squared all over 45. You can do this 6 times. 1, 2, 3, 4, 5, 6, 6 times. And you get a value of. I have several numbers on my page. I have 4.68. I think I have 4.685. Okay. So again, this is close to this number. So again, I don't have what my exact number is, but clearly we did this. Okay. So this is 4.61. 4.685 is here. You're going to reject HO, right? Gender and job satisfaction are related, right? For the exam tomorrow, you will not have calculations will be that close. It'll be very clear whether it's an accept or reject, right? Because again, I think depending what you do for rounding, I think you could get a number that's below 4.61 depending on how you round it, I think. See, unfortunately, I've got too many calculations on my correction sheet. Again, p-value, chi-dist, 4.685, degrees of freedom, 2. Questions? Okay, there we go. Let's do Turnpike City School. Okay. And again, this is a case. This will be on the test tomorrow. Okay. All right. So essentially what this is, Turnpike City School. Anybody know what Turnpike City is, by the way? Turnpike City is Boston, right? You know, if you hear in the United States, if somebody's called the Motor City, anybody know what's the Motor City? Anybody know?
Chicago.
The Motor City is known as Detroit because where all the cars are made. The Windy City is Chicago. The Bay City is San Francisco, right? Liberty City is Philadelphia, right? Watch City, which you may not know, is Waltham, right outside of Boston. Again, these are all trivia. Don't need to know. Anyway, so what they're alleging is they're actually saying it's a discrimination, and they're saying it appears to be that teachers with graduate degrees have more non-minority students in their classroom. Right? That's what they're saying. Right? So clearly, here's our distribution. Right? So this is 40, this is 60, this is 40, this is 60. Grand total of 100. Okay. So our HO and H1 is they're saying the variables are independent, or they're saying that teachers' education level and number of non-minority students in classroom are independent. And then teachers, blah, 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 are not independent. Right? So H1 is alleging that there's something going on there, and that this is not done by a random chance, that, you know, there's some sort of known discrimination going on there. Step 2 is reject HO if chi-square calc.
So could you move the camera?
Pardon me?
Oh, we can't see the.
Yeah. Sorry, I didn't zoom out far enough. There we go. Sorry about that. Z-calc, if it's greater than some number, and again, it's 0.0. Again, the alpha is not given to you, so then again, you always assume 0.05 unless you're told otherwise. So 0.05, right? And it's going to be number of rows is 2 minus 1 is 1. Number of columns, 2 minus 1 is 1. So therefore, your degrees of freedom is going to be 1. So 0.05, 1 degree of freedom is 3.84. Okay. So we have to do our expecteds. Now remember, this is still good. This is observed here. This is going to be your expecteds. So 40, 60, grand total of 100. This is going to be 40 and 60. We only need to find one cell because of 1 degree of freedom. The rest can be done by subtraction. So 40 times 60 is 2,400 divided by 100 is this is 24. So if this is 24, this is going to be 16. If this is 40 and this is 16, this is going to be 24. If this is going to be 60 from 24, this is going to be 36. Okay? 24 and 16 is 40. 36 and 24 is 60. 60 and 24 is 40. 24 and 36 is 60. All equals 100, right? So the distributions have got to be the same as far as the margins. Okay? So chi-square calc, 20 minus 24 squared all over 24 plus 20 minus 16, again, 20, 16 squared all over 16. The next one, 40 and 36. 40 minus 36 squared all over 36. And the last one is 20 minus 24. 20 minus 24 squared all over 24. I believe when you do this out, I think it comes out to be 2.78. .84, where this is 0.05, 2.78 is here, except HO. Education, level, and number of non-minority students is independent or not related. Questions?
Wait, so this means that there's no discrimination, right?
Yeah, we're saying they're not related.
Okay.
Okay, so this case is going to be on the exam. As I mentioned before, a case question on an exam, what it really means, it means that you should know the case well enough that we're going to use the numbers from the case. Okay. Now, I would never have you redo the case, but I could ask you something about this case, right? I could ask you, again, I could ask you an alpha and beta question, right? I could ask you I could ask you to read, kind of look at the question and say, okay, what if your alpha was not 0.05? What if it was 0.1? Would it change your answer? Right. So again, I could ask you some variation or some variable. I would never change. Again, it would never change the question. I would say, okay, here's another class in another school district. You would never redo the whole thing from scratch. Right. There'd always be some kind of subset of that. Okay. Kind of like what we did for the why choose me case. Right. The why choose me case, there were several sections. I only asked you one question about one little section. Okay. Any questions? Okay. So again, as I said, I want to thank you all. If you think about all the stuff we've done in this course, we've actually done quite a lot, right? So starting with probability and then talking about doing sampling, right? And then going to Bayes' rule and then different accounting techniques and the decision analysis, and then talking about the distributions for the Poisson and the binomial, and then the normal, and then doing confidence intervals, and then doing things where sigma is unknown using the t-curve, right? And being able to figure out sample size. And then we jumped to doing hypothesis testing. So we did hypothesis testing with the means, hypothesis testing with proportions. We did 2 sample testing. We talked about errors and what that means. Then we talked about paired data. And then we're talking about the chi-square distribution. So we think about what you didn't know at the beginning and what you know now, right? Again, a lot of you that have had stats before, I've heard from a lot of you. Again, I think most of you told me that, oh, we definitely learned things in this class that I'd never even seen before. Well, that's the whole point, right? So as I mentioned before, I felt it's been a good experience. Again, it's not ideal to have this over Zoom versus in person, but I don't think this class suffers too much. And again, as I mentioned, for those of you taking me in for 222, I've done 222 now Zoom. I'm one of the only people that has done it now. Matter of fact, I'm the only person that's done 222 totally by Zoom, right? Other teachers taught it in the spring when it was halfway, but I taught 2 sections summer 1, so I'm the only person that's done it. So, and I think it went very well. So I think other classes may suffer more going with a Zoom platform, but I think a course like this actually goes well. So again, it may not be ideal, but I think you're not really losing anything. Okay, so that's good. So what I'm going to do is I'm going to send a link. I'm going to put it through the chat function of the what you need to do to open up to do the course evaluation. Okay, so I'm going to send that to you, and then I'll set the timer probably for 15 minutes or so, and we'll come back in 15 minutes, and again we'll come back and we'll do our review problems. So again, I want to thank you all for this, everything. So let me just set this up for everybody. Great. So I sent everybody that's the link for the course evaluations there. So I'll set the timer, come back in 15 minutes. I'm going to refresh my coffee, and then we'll go over the problems. So we're in good time today. Okay. So thank you, everyone. Welcome back, everyone. Thank you again. Thank you for filling out those forms. It's always important to get feedback on a class and know how things are going. Okay. Let everybody get their cameras back on. And we'll start going through the review problems. As I stated before, right? Hopefully by now you've seen how I've been doing problems and kind of the rules I've done. Again, if you follow the rules, you won't get lost, right? So I think if you are very cognizant and again, read the questions carefully, right? You got plenty of time to go through. So I think you'll do just fine. So I certainly wish you all well, you know, getting ready and finishing this class. I don't know what you're going to do the next couple of weeks. This is going to be my first, significant time off, more than just a few days, in probably more than a year for me, right? I mean, other than around the holidays, right? Because unfortunately around the holidays, obviously busy time, but obviously, you know, for you students, you finish your finals and go home, but we, you know, faculty, we do all the grading and stuff and get ready for the next semester. So it's going to be interesting. So I've certainly got a lot to do. Like I said, I've had meetings every day talking about what we're going to be doing in the fall and how classes are going to run, et cetera, et cetera. So it's kind of, it's been interesting. So it's a lot of fun. So hopefully I'll have sometimes some fun stuff for the next couple of weeks before we start it up again. So if I'm lucky, again, that you saw me when I was zooming with the pictures of the loons behind me, my summer cottage. Hopefully I may be able to get it back up there for another week. I guess I've got to see my family. So as I mentioned, I was up there on up there on quote unquote vacation, where I was zooming with you and my family was off. But now I'm able to go up with my wife and I, and my daughter may go up, but the two of them would have to work, but I would be off. So it'd be a little bit different. So, you know, again, this pandemic, you try to do the best you can do, try to see the silver linings is what you can, right? As I mentioned, you know, I mean, we've been very fortunate to have our daughter here. You know, I said she's in her late 20s, so it was fun to have her home. And she's actually in New York this week, but she'll be maybe coming back next week. So it's been fun to have home and seeing family, stuff like that. And like I said, we're all, you know, I'm in great shape. I'm eating better and all that sort of stuff. And my yard looks beautiful at my home. But, and I've been able to do some exercise, but, you know, do what you can. Do what you can. So you just got to keep, you know, something different, something new, learn from the environment and see if we can get out of it. Okay, enough of that. All right, so let's go to, let me share my document camera with you and let's start the problems. Okay, suppose that one wishes to determine whether or not proportions of BU student, proportions, keyword, again, proportions means that it's going to be some kind of proportion problem. Watching Monday Night Football has changed from last year when it was 1%, 10%. If one takes a random sample of 400 BU students and finds that 28 watched Monday Night Football, is there evidence at alpha 0.05 that the change in proportions has taken place? Okay, so we have HO and H1, right? It's P and P, something to do with 10%, right? Because this 10% is the alleged proportion. We want to know, has a change happened? A change can be greater than or less than. So therefore, it's going to be equal or not equal. It's going to be a two-tailed test, right? So again, you've got to read the question carefully to determine what kind of relationship it is and what they're saying about the hypothesis. Your step 2 is reject HO if Z-calc, right? Why is it a Z? Because it's a proportion problem. So proportion problem is a Z, right? Same, it's going to be greater than some number, less than something else, right? So 0.05. So again, you have this right here, right? This is always the total alpha. So that means it's going to be 0.025 and 0.025, right? So on the Z, 0.025, 0.025, it's to be what? 1.96 and negative 1.96. Right? 1.96, because you look up 97.4750. Okay? So 1.96, negative 1.96. Okay? Do your test statistic, right? So it's Z-calc is P bar minus P all over square root of P, 1 minus P all over N, right? The whole thing is square rooted. Our P bar is 28 out of 400. So 28 out of 400, which is what? 0.07, right? That's your P bar. So 0.07 minus 0.10 all over square root 0.10. Why is it 0.10? Always the P alleged in HO, right? Always the P alleged in HO, right? So it would never be 0.07 times 0.93, right? That equals -2. -2 is here. You're going to reject HO, right? Yes, change has occurred. Questions? Oil experts have claimed the number of miles driven by consumers is increasing due to lower gas prices and automobile gas mileage ratings. They drove 17,526. Sample of 25 drivers revealed an average of 18,640. So this is your X bar. This is your mu. This is your N. right? Standard deviation, this is a sample standard deviation. This is your S, right? 0.01. I think this is exactly like a homework problem or very similar to a homework problem we did. Okay, so HO and H1, right? Mu, something having to do 17,526, 17,526, right? We want to know number of miles driven by consumers is increasing. So that's a greater than sign. It means it's less than our alpha. Step 2 is reject HO. If T calc, right, it's a T because you have S, sigma is unknown, right? T calc greater than some value, right? So your N is 25, so your degrees of freedom are 24, right? With my handy dandy T chart I have right here, right? Our alpha is 0.01. So this is definitely a one-tailed test. So 0.01 is this column right here, 0.01. So I'm going to go down this column. Go down this column until I find 24. Right, 24. That value is 2.4, 2.492. 2.492, right? Is your step 1, step 2, step 3. Is your T calc. So 18,640 is your X bar minus the mu, 17,526, right? All over your S, 1,000 square root 25, which is going to equal 5.57. So again, reject HO, right? Yes, driving more. There is evidence that people are driving more. P-value would be T-dist 5.57. Degrees of freedom, we know, is going to be 24. And it's a one-tailed test, so it's a 1. Going back to the prior problem just to do it, -2, p-value would be look up 2, which is 0.4772 on your Z, right? But you want the value, right? You want the value to the tail. So 0.4772 is that area there. So therefore 0.5 minus 0.4772 would be 0.0228, and that would be the p-value there. The question didn't ask for p-value, but I decided to do p-value. Question. Okay. All right, so number 3 is kind of a little different question. All right. So basically what you have is, you've got this question, this is theory, right? Talked about HO. Now, what do you really want to know? You really want to know H1, because that tells you, ba-ding, you know there's going to be a shift. Okay, so here are the 4 questions, and of the 4 questions, here are the answers. So for 1 or I, it's A, B, C, or D. For 2, it's something else. Now, it doesn't mean an answer cannot be repeated. Okay, so let's draw this out. Because of H1, we know the critical point is one-tailed, it's here. And we know this is alpha, okay? Therefore, we also know, right, this is X sub 1. We also know we telescope that down, right? This right here is going to be beta. This area here that's unshaded is 1 minus beta, known as power, right? Get my pens back up here, my different color pens. This here is known as power, 1 minus beta. Okay, so if mu sub 1 is the true mu, and mu sub 1 is greater than mu sub 1, the larger this distance. Okay, so in other words, if this actually grows, meaning if this shifts more to the right, meaning it looks like this. Right, I'm shifting it. Right, it shifts to the right. What happens is this telescope's here. Clearly, my beta went down. My power went up. Right. So this is going to be B. The larger the power of the test is. Right, because what happened was because there was a shift and the graph went to the right. The smaller the significance level is. So if alpha gets smaller, again, what happens here, let me draw this over here. Right? This is beta, and all of this is power. Right? If alpha gets smaller, what happens? If alpha gets smaller, telescoping this down, beta then gets bigger, 1 minus beta is going to get smaller. So that's going to be A. These two are actually the same, right? So if this is my original, if this is, let me just draw it right here. Right? This is my alpha and this is beta. This is mu sub 0 and mu sub 1. So there's no shift. If the smaller the population standard deviation, if sigma goes down, what happens? What happens is the graph gets taller and thinner. Look what happens. Look what happens. See, alpha gets smaller, and then down here, it's going to get taller and thinner. But this distance hasn't changed. But this area here is smaller, and it's smaller here. So therefore, what? Power gets bigger. Right? So that's going to be B. For a sample size of N, it's exactly like this one. Again, it goes up taller, it gets taller and thinner. So this is these two are exactly the same question, just worded differently. So this answer is also going to be B. So it's B, A, B, B. And this question can all be done just by understanding theory and understanding manipulating the graphs. Also known as, do you understand what it means?
Professor,
Student?
when do you know it's gonna be a right shift?
If it's going to be an upper tail shift?
Yeah.
Because of this. That's why I always look at HO, H1.
Oh, okay.
Right, always. That's why whenever you're given anything about HO and H1, it's really H1 that you want to know, right? We talk about HO, but H1 is what you're going to use to formulate the question, always, right? Because again, this tells you, ba-ding, it tells you it's an upper tail test, and it tells you that it's a one tail. Okay, moving on. Large domestic airline operating in the United States claims its service is so efficient that on average, airplane doors open for passengers disembarkation. 70 seconds, right? So that's your mu after plane completes its landing. And agency wants to check this claim, which it suspects is exaggerated. This is very similar to a problem that I put on our quiz, right? All right. So what they're saying is they're claiming you get off in less than 70 seconds. They're thinking it's exaggerated. So so what they think is they think the claim is actually it takes longer than 70 seconds for it to get out. So the claim is going to be H1. So basically HO is going to be that it's less than or equal to 70 seconds, right? So again, you have to get that from the wording of the question, right? I'm going to star that because again, this is a good example of how you've got to use a question to figure out, read the question carefully to figure out what it's talking about. Since there have been many passenger complaints, the random sale of 16 flights, there's your N, X bar, that's your X bar is 72, and S is 6, that's your S. So that means you're using the T, right? Is there evidence to refute their claim? Use alpha 0.05. So HO and H1, right? So clearly you're talking about whether mu something around 70. We discussed this up here. So really the agency thinks it's exaggerated. So therefore it's going to be greater than 70%, 70. This is going to be less than or equal to 70. Step 2 is reject HO. If T-calc, right? Sigma is unknown. Use T, right? Same sign, greater than some value. Your N is 16, so your degrees of freedom have got to be 15, okay? So again, looking at I'm not going to zoom in this time, but if you find it's 0.05, one-tailed test, 0.05 down here, 15, use your 16, so using 15 for degrees of freedom, it's 1.753. So 1.753, right? You do your test statistic. It's going to be 72 minus 70 all over 6 over square root of 16, which is going to be 1.33. So on your T-chart, right, this is 0. 1.753, 1.33 is here. You're going to accept HO. Right, accept HO, meaning yes. Is there evidence to refute the claim? No evidence to refute claim. Marshall Bank and Trust offers cell phone bill paying services for its customers. Originally, the bank charged $5 per bill. Again, you don't care about that. This is just a metric, as you say, as I say, metric, right? Found that customers using the service paid an average of 9.5 bills, right? So that's your mu. That's how much they pay per month, with a standard deviation sigma of 4 bills. So that's given to use 4 bills. Last month, the bank withdrew the service charge and offered the service for free. This month, the bank sampled 36. There's your N, and found an average bills paid was 10.5. That's your X bar. Using a significance level of 0.01, that's your alpha. Does the bank have evidence that the change to free service has led to an increase in the number of bills? So an increase. So you want to know if it's increasing, right? So clearly HO and H1. Mu, something 9.5, nothing 9.5. Again, you're talking about the alleged mean. The alleged mu is what's given to you. We want to know if it's increasing. So that's going to be greater than. Back into HO, that's less than or equal to. Reject HO. If Z-calc, right, because you have sigma, if Z-calc, same sign, right, same sign, greater than, alpha is 0.01. So 0.01, right, this is 0.01, this can be 0.4900, which is what? Which is 2.33 on your Z-chart. So 2.33. Again, you should all know how to do that by now. Do your calculation. You're going to do 10.5 minus 9.5 all over 4 square root of 36 is going to equal 1.5. So again, 1.5 is here because it's 2.33. You're going to accept HO, meaning no change, right? There has not been a significant increase in the number of people paying their bills online. P-value for 1.5. 1.5. 1.5, if you look at it, is 0.4332. 0.4332 is that area there. You want this area here. So 0.5 minus 0.4332 is 0.0668. Remember, if indeed this was an equal, not equal, to two-tailed test, you take this value and you multiply it by 2. Don't forget that. Answer. Question. Comment. Okay. Suppose the storage knows that 20% of all past accounts receivable were delinquent and decides to institute a new credit policy which gives a discount for incentive to pay on time. This year's proportion of delinquent was 0.14. So again, 20%, that was the population proportion. This is P bar. It's 14, right? i.e. P bar 14. Your N is 100. Is there evidence to conclude the incentive has worked? HO and alpha 0.05, HO and H1. P, something to do with 20%. We want to know if there's been a decrease. If there's been a decrease, is less than. So greater than or equal to. Reject HO if Z calc, right? Less than a negative, again, 0.05. If this is 0.05, this is 0.4500, which is what? Negative 1.645. 1.645. Test statistic, 0.14 minus 0.20 all over the square root, 0.20, 0.80. Remember, always the P alleged in HO all over 100 is negative 1.5 in this case as well. 1.5 is here. Your step 4. This is step 1, step 2, step 3, step 4. Accept HO. Right? Is there evidence that it's worked? No. No evidence. Incentive worked. P-value would be the exact same thing as the last problem, actually. 0.0668 again. Negative just means to the left. Remember, there's Z chart. Positive, negatives. This is 0. Questions? Early 1970s, students started a phenomenon called streaking. I remember that. Within a 2-week period following the first streaking is obviously taking off your clothes and running around naked. So if you don't know what that means. A standard psychological test will give a group of 19 males, right? So that is your N1 who admitted streakers, and a control group of 19 males, that's your N sub 2, who are non-streakers. The following data regard their scores, right? So this is X bar, this is X bar of 1, this is X bar of 2, the standard deviation. Is there evidence between the two groups? A difference between the two groups? So clearly alpha 0.05. So HO and H1. Mu sub 1 different from mu sub 2. Mu sub 1 is different, not equal to mu sub 2. Right? Is there a difference? Okay. So you're going to reject HO if tcalc is greater than some number, less than something else. Your degrees of freedom are 18 from one group, 18 from the other. So it's 36. Right? So therefore, looking on your t-chart, alpha 0.05. This is a two-tailed test. So 0.05 is this column right here. There's 35. You can't find it. So you find 36 over here. So it's in this chart here. 0.05, 36 is 2.028. -2.028, -2.028. Okay. So then you do a test statistics. Now remember, what you've got to do is you've got to calculate your SP squared. Your SP squared is N1 minus 1, so it's 18 times S1 squared, so it's times 2.62 squared, plus N2 minus 1, which is 18 times 4.11. 4.11 squared all over 18 plus 18, right? So then we do that, and then you find the square root of that value. You find the value is going to be 11.88. Oops. I'm sorry, that's not right.
Square rooted.
No, the SP squared is 11.88. So if you do the square root of that, and that's going to be, oh, I don't know what that is.
3.446.
1.46?
3.446.
Oh, 3.446. Thank you. Okay. 3.446. Okay. So again, I want to check that number. It's between these two numbers, which is great. The ends are the same. So it should be halfway in between, a little bit bigger, which indeed this is. So then you just have to do, so then your test statistic is 15.26, right? Minus 13.9 all over 3.446 square root 1 over 19 plus 1 over 19. Now, if you wanted to do this, you could write this, an alternative way to write this, which is fine. Either way you can do it, is you could write this as 15.26 minus 13.9, and then you can put the whole thing on the radical and put this number there. So it could be 11.88, 1 over 19 plus 1 over 19, right? You could write this way. They're both the same, both synonymous. Okay. So basically, when you do this out, it equals 1.21. So again, on your looking at your graph, 2.028, negative 2.028, 1.12 is here. You're going to accept HO, meaning there appears to be no difference between the two groups. No difference in the psychological testing. P-value. P-value would be T-dist. Your value of 121, 1.21 is your cutoff. Your degrees of freedom are 36, and that would be 2 because it's a two-tailed test. we are testing HO, mu is equal to 20, mu is not equal to 20 by using X bar from a normal distribution. We compute S to be 6 and sample size to be 9. At 0.05, the acceptance region is blank, okay? You know that this will never be an answer. Okay, so what we know is we're trying to find the acceptance region. The acceptance region is the same thing as finding the confidence interval, right? So you know it's going to be X bar, no, excuse me, you're going to find it's going to be mu plus or minus E to get the confidence interval, which is going to be acceptable range. So it's going to be 20 plus or minus E. So it's going to be 20 plus or minus, right? Your sample size is 9 and you compute S. So it's going to be T1 minus alpha S over radical N. So 20 plus or minus, right? T1 minus alpha is 0.05, right? And you know your sample size is 9, so therefore your degrees of freedom are going to be 8, right? So looking at your T distribution, 0.05, degrees of freedom of 8 is 2.306. So it's going to be plus or minus 2.306 times S, right? So it's going to be 6 over square root of 9, which essentially is going to be 20 plus or minus 4.612, which clearly means it's going to be this one. Suppose in the previous problem, we ended up accepting the null hypothesis. We might be committing a type 1 error, a type 2 error, either a type 1 or a type 2 error, neither a type 1 or type 2 error, or none of the above. Okay, I'm going to make this a little easy for you. Clearly, that will never be an answer. Okay. Either a type 1 or a type 2 error, right? It can't be either, because that implies it can be both. It can't be both. Neither means that you won't have either one of them. It can't be that either, right? So clearly every problem has a type 1 and a type 2 problem, type 2 error, every problem, right? So it's gonna be one or the other. So the answer is gonna be either this or this, okay? So if you're accepting a null hypothesis, remember, a type 1 is rejecting HO. One should reject HO. A type 2 is accepting HO. When should, oops, sorry. This is accept. This is rejecting when you should accept. This is accepting when you should reject. Again, they're kind of inverses of each other. Okay? You end up accepting. So accepting HO is this one. So clearly the answer is going to be a type 1 error, type 2 error rather. Maybe a type 2 error. Again, this is another theory question. Suppose we're testing HO, mu less than or equal to 1, mu greater than 1. Again, we want to know this. So what we know is We know the graph looks like this. HO less than or equal to 1, H1 mu greater than 1. So we know this mu is going to be 1. Okay? With a standard deviation of equal to 1. Standard deviation is equal to 1. If alpha is 0.05, so this is 0.05, and beta is 0.01 when mu is 2. So what you know is here, there's going to be a cutoff somewhere, right? Again, this telescope this down. This on this chart has got to be 2, where this is 0.01, right? You have to figure out what is the sample size used, all right? So essentially, like other problems we've done before, we're going to set two equations equal to each other and solve for the unknown. All right, so this one here, the critical value for this one here is going to be 1 plus, okay? This is 0.05. This is 0.4500, 1.645 times 1 over square root of n. This one here is going to be 2 minus, if this is 0.01, this is 0.4900, which is what? 2.33 minus 2.33, 1 over square root of n, right? So then I set these equal to each other. So if I do 1 plus 1.645, 1 over square root of n equals 2 minus 2.33, 1 over square root of n, right? What I can do is I can add, I can add 2.33 to this and then take 1 to this side. So basically, if I add them together, this is 3.978, I think, is going to equal 1, excuse me, and then add one that's going to be equal 1. Sorry, 3.978 is going to equal sorry, let's screw that up. Switching this side, it's going to be 3.978 over square root of n, right? Because it's over 1 is going to equal 1, right? So basically multiply by square root of n, I get 3.978 is going to equal square root of n. So then I square this, and you see this is approximately 16. So 16 is going to be that number right there. One month before the presidential election, we poll a sample of 30 students. There's your N. Undergraduate program, letting P represent the true proportion of BU undergraduate students who favor a Republican candidate. We formulate the null hypothesis. HO is P is less than or equal to 1/2. In other words, the null hypothesis says in the sample of 30, less than 15%, 15 students favor Republican. In the student body, less than 50% favor Republican. In the student body, less than 50% favor a Republican. In the sample of 30, 50 or more in favor of a Republican candidate, none of the above. Okay. Well, clearly can't be that answer. This says in the sample of 30, so that's out of n. This is out of the population, capital N, and little n. Remember, this always deals with the population. So it can't be this answer, and it can't be this answer, right? Null hypothesis is greater than or equal to 50%. So in the student body, at least 50%, right? At least 50%. So the answer is going to be C. Again, another theory question. In problem 11, a type 1 error would assert that, remember, type 1 is reject HO when you should accept HO, right? Again, you've got 4 answers. None of the above clearly cannot be an answer. All right. So type 1, now remember, this is, it's greater than equal to 20%, 50%, right? So this is 0.5. So H1 is going to be less than. So the critical point is over here. So a type 1 error is on this side. So we know we're showing less than 50%. So less than 50% of student body favor Republican when the true P is 0.5 or more. That sounds like a good candidate. 50% or more of the student body favor Republican. No, that's this side. It can't be this one. Less than 50% of the student body favor Republican. No. Can't be less than 50% because again, it's going to be accepting. It's going to be rejecting HO, and HO is right. HO is mu is greater than equal to 1/2. So it's rejecting that it's not greater than. So it can't be either one of these. So the answer must indeed be A. Again, this is another theory question.
Could you explain it again, please?
You know this one here. So you know that this says it's greater than or equal to 50%. So this is so H1 is this way, and this is going to be something less than. So a type 1 is rejecting HO when you should accept HO. So it's rejecting that. It's rejecting that less than 50% of the student body favor Republican when the true value is 0.5 or more when HO is true. And HO is greater than or equal to 0.05. So it's got to be A. So it's concluding that less than 50% of the student body favor Republican when they really do. They do favor. More than 50% do. If you look at this statement and just figure out how it fits it. See how it fits in that problem. It can only be A. Suppose in problem 12 we end up rejecting the null hypothesis. Again, this is 0.5. This is some value less. You get this thing. So you're rejecting HO. Okay. Now again, A, B, C, or D, or E. Ishkabibble. Right? Moby Dick. Can't be that one. Okay. We are definitely not committing either a type 1 or type 2 error. That one can't be right because you got to be doing one or the other one. It's possible we're committing a type 1 error. It is also possibly committing a type 2 error. Can't be. It's either one or the other. Can't be both. It is possible we're committing a type 1 error, not possible committing a type 2 error. It's possible we're committing a type 2 error and not possible we're committing a type 1 error. Well, if you're rejecting, remember, type 1 is reject when should accept, and type 2, and again, I'm abbreviating, a type 2 is accept when you should reject. If you end up rejecting is rejecting, so basically it's going to be type 1. So therefore, it's going to be possible you're committing a type 1 error when you're not possibly a type 2 error, right? So it's got to be C. Because the rejecting, right? It's when you reject when you should have accepted. So if you reject, you should have accepted. That's a type 1 error. Okay. So essentially, we're trying to look at the usefulness select different samples of respondents, differences in similarities and samples of their respective population, right? So this is actually from a real study out of this educational journal, all right? So basically what you have is, you've got married professionals. There was N1, that was 162 of them. The percent that were males was 95. The marital status, 91% were married. And then part-time students, this is N sub 2. This is a P, what percent that are males and the part that are married. Does the population of managers and professionals consist of more married individuals than part-time MBAs? So the gender one, we can get rid of this. We don't care about this at all. Right? So what I'm going to do is I'm going to do this on another piece of paper. Okay. All right. So 162, 109, this is 0.912 and 0.534. All right. So this is, let me see, this is managers and professionals. R2 is part-time MBAs, right? So our N sub 1 was 162. Our N sub 2 is 109. The P bar 1, right? We're thinking that one is
91.2.
Yeah, 0.912. And for the other one, P bar sub 2 is 0.534, right? So we want to know our HO and H1 is we want to know whether the P for the managers and professionals, whether or not it's less than or equal to of the MBAs, right? So managers and professionals is greater than MBAs, right? Hold on one second. Again, I'm looking at my notes. My notes, I have different variable names. Right. Okay. So you're going to reject HO if TCalc greater than some number, right? So the thing is, our alpha here is 0.01, right? So clearly our N's are too big to use a Z. So you're going to use value from the Z, right? So 0.01 means you look up 0.4900, which is 2.33. So greater than 2.33. Okay? So then you have to do your test statistic. So what you have to do is you've got to do, it's your test statistic is TCalc is going to be P bar 1 minus P bar 2 all over SP 1 over N1 plus 1 over N sub 2. Your SP is your pooled P times 1 minus your pooled P square root. Your pooled P is just a straight weighted average. So it's 0.912 times 162 plus 0.534 times 109, that's your N, all over 162 plus 109. When you do this out, it actually ends up being 0.76. So therefore, using this as your pooled P, the calculation is then going to be 0.912 minus 0.534 all over the square root of 0.76 times 0.24. And then you're going to multiply that by the square root of 1 over 162 times 1 over 109. And that's an equal 7.14. So again, on your T chart, where this is 2.33, this is 0.01, 7.14 is here, you're essentially going to reject HO. Okay. M&M, this is from a real study, by the way. Plain and chocolate candies, blah, 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 different colors. This is what they think they should be. They should be 30% brown, 20% yellow, 20% red, 10% orange, 10% green, 10% blue, right? So the results of 370. So 370 was your N, and these are your observed, right? So what we want to do is we want to calculate the expecteds. So the expecteds are 370 times 30%, right? So that's going to be 111, right? So 30% of that. Then it's going to be 20% for the next two. So that's going to be 74 and 74. And then 10% is going to be 37, 37, 37, and 37. Okay? So the chi-square of this. So the chi-square is going to be these two. So it's going to be 84 minus 111 squared all over 111 plus the next one, 79 minus 74 squared all over 74. You do this all the way out. And when you do this, you get a value of 13.54. Okay? Conduct the test to determine whether the true percentage of colors is different from the manufacturer stated. Okay, well, clearly what you're going to do, alpha 0.05. So what we can do, I'm not going to write out the whole thing, but what we can do is 0.05, right? You know the number of categories, 1, 2, 3, 4, 5, 6. So 6 categories. So K minus 1, right? So it's going to be 6 minus 1. It's going to be 5 degrees of freedom at 0.05. On your chi-square chart, 0.05, 5 degrees of freedom, 11.1. So if I do this here, this cutoff is 11.1, 13.54 is clearly here. We're going to reject HO. Does not follow the percent distribution, right? So clearly what they're doing is they have this differently. Sorry, I didn't paginate this last problem correctly. Sorry. So this is the next problem begins here. Siskel and Ebert were famous movie critics. Again, you don't know them because I think they're both dead now, but they were very popular, and they were movie critics, and it was a very popular program that was on PBS, right? So it was on a long time. So basically what they wanted to do is they wanted to look at whether or not how Siskel rated the movie, whether it was, this is Ebert, whether it was independent on how Ebert rated the movie, right? So they look at this thing. So basically what this means here, right? So 24 out of a total of 160 movies, 24 of those movies, Ebert gave it a thumbs down, Siskel gave it a thumbs down. On 64 of the movies out of 160, Ebert said, yep, good movie. Siskel said, Ebert said good movie, Siskel said good movie, right? And these are all the other times where they kind of had a mixed review or they, disagreed. Okay. So it says, verify the expected cell counts in the table are accurate. Well, which ones are the expecteds? So if you didn't even have this, you would know that the expected ones are these because they're the ones with the decimal places, right? So what you can do is you can look at expected. So you have to do a couple of them. So if I do this one, if I want to do this expected count for 11.8, I take row total times column total divided by grand total, I'll get 11.8. If I choose another one, if I do the 6, right? If I do row total times column total divided by grand total, it'll be 6. Okay?
Do we have to check the whole thing?
No, not at all. Again, you would never have a problem like this on a test. This is just what this is what they're doing to help you learn how to do this. Right? This is just a problem. Okay? All right. So first thing you want to know is you want to know your degrees of freedom, right? The number of columns, 3. So 3 minus 1 is 2. The number of rows is also 3 minus 1 is 2. Multiply them, you get degrees of freedom of 4. Your alpha is 0.01. Okay? So you know you're going to reject HO. Remember, what you're trying to say, your HO and H1 are the critics' views are independent. Critics' views are not independent, right? If you're saying they're independent, how Siskel rated a film and how Ebert rated a film are independent. H1 is that it looks like they're in collusion, or basically they rate the things the same. To reject HO, right? If chi-square calc is greater than some number, again, it's 4 degrees of freedom, alpha 0.01. .01, 4 degrees of freedom, right, is 13.3. Okay. Okay. So then you have all the stuff to do the chi-square calc, right? So you do 24 minus 11.8 squared all over 11.8 plus the next one, 8 and 8, 4, 8 minus 8.4 squared all over 8, blah, blah, blah. Do that 9 times. And when you get this out, you see it equals 45.4. So clearly, sorry, right? So 24 and 11.8. 24 minus 11.8 squared over 11.8. 8 minus 8.4 squared over 8.4, actually, sorry, 8.4. Do this out 9 times, you get 45.4. Clearly on your chi-square chart, this is 13.3. 45.4 is here, right? So it does appear they are not independent. So in other words, it does appear that they were how one rated does affect how the other one rated. Interesting. Last problem. Okay. So what you have is auto dealer thinking about a new incentive plan, 7 employees, there's your N, was chosen at random and their weekly commission is based, it were recorded. Okay. So this is before the incentive plan, new incentive plan. We gave you the difference, right? The difference D bar is 60.7. Again, this must be given to you. And the standard deviation was also given to you. All right. So I just said, once you're given this, you can do it by hand, right? So HO and H1, right? You want to know whether mu sub D and mu sub D, whether the average distance, in this case, we want to know if it worked. So it should have what? Increased. The one does not increase. Okay. So you're going to reject HO if tcalc is greater than some number. So there's 7 people. So your degrees of freedom are 7 minus 1 equals 6, right? 5% significance. So again, looking at your T chart, right? Sorry, 0.05. So 1 significance, 0.05 here, 6 is 1.943. So 1.943. Okay. So then your tcalc is simply 60.7 minus 0 all over 49.7 all over square root of 7, which is 60.7 all over 49.7 all over square root of 7, which equals 3.23. Right? Where this is 0.05. 3.33 is here. I'm going to reject HO, right? Incentive has increased sales. Woo! There we go. That was a long haul. You guys did a great job. On Questrom tools, I will post. You just saw me go through the answers. I will post an answer sheet as well. So if you don't necessarily want to go back and have to look at this recording to check your answers again, you can just print out the sheet. So the sheet is done out as a handwritten form, but it should definitely help you. Okay. So first questions. Anybody have a question in regards to something about the exam for tomorrow?
So, Professor, you've done the Turnpike schools. Will you post the solution on there,
Yep.
or?
Yep, the solutions always be posted right after I do it. So today, again, you want to print that out for you as well.
Got it. Thank you.
Welcome. Okay. Any other questions on the exam? Okay. Any questions having to do with grades or anything like that?
For the final grade, like, so if the final grade is like a 80, then is that a B minus or a B, or is that just
grading goes by fives, right? So I'll do this on my I'll do it on my document camera. Good question. So generally speaking, what it normally is, it goes by fives. So a 95 to 100 is an A. A 90 to a 90, 95 or 94.99 is a A minus. 85 to 90 is a B plus. 80 to 85 is a B. 75, that's the key number, 75 to 80, or 79.99, right, 99 is a B minus. And then so 70 to 75 is a C plus. 65 to 70 is a C, and then 60 to 65 is a C minus. Oops, C minus, right? Now, generally what we'll do is, again, you get a 90, it's very hard to get a 95 because you get 1 point. So basically this is actually relaxed. This is like a 93, and this is like a 93. So what happens is the category for an A minus is actually smaller because most people, if you get in the 90s, you're gonna get sucked up into an A anyway. So that's a benefit for you. Now, again, I say again, you've got to make sure of a couple of things, right? I said this in earlier class, you cannot receive a final grade in this class that you did not also receive on at least one exam, okay? So my example is, based on my numbers I gave you, if you received a 74 is a C plus. If you got a 74 on exam 1, a 74 on exam 2, and a 74 on exam 3, if you are a star performer, you came to office hours, you participated more than anybody else, you got hundreds on all your quizzes, your final grade is still a C plus. There's nothing I can do about it. It's not my rule, right? So you got to have at least achieved that grade. Now remember, as I said before, some of you that have, you want your final to be your best grade, right? If you get a 95 and a 95, and then on the final you only get an 80, are you getting an A minus? You're probably not getting an A minus. You're probably not even getting an A minus anymore. Right? It's the other way. It's much better to get 80, 80, and 95s on the final than to get 95, 95, 80s, right? So the final really is, the final is, okay, I've known my stuff. I've learned your style. I know the types of questions. You're not going to fool me. I got it, right? So again, I don't think you need to go overboard. I don't think you just, don't pull an all-nighter, right? I would definitely, again, the way I would study for this, I would study by topic. So do the hypothesis testing of the means. So you understand those topics. Do you understand that question? Have you done the Parker problems on hypothesis of the means? Okay, yep, check one off. I know that one. And then do hypothesis with proportions. I've done the homework problems. I've looked at the slides. Again, I've done the Parker problems. Great, thumbs up. And then with errors, all that sort of stuff. So I would study by topic. Then I would review these review problems. Again, and they should be in good shape. Again, it's open book, open note. You're not gonna have time to find something, right? So you just wanna make sure things are well organized. So you should definitely know all the p-value commands or calculations, right? You know the rules for p-value. You know what it means for a type 1 or type 2 error, right? You have that written out on a piece of paper. Again, if I was you, I would definitely make a cheat sheet is what I would do. I think if you do that, it'll show everything's organized. And again, the fact of writing a cheat sheet tells your mind, this is important to know. I want to memorize this. So that will help you. Okay. All right. So again, please check your grades now. If you email me about an error over the weekend, it may be too late. Okay. So I want to, because again, I can't be going back to all these calculations we're done. So again, I think I posted grades all along, right? It should be good. Again, the KP OTDs, The key points of the day, yeah, I mean, I look at those, but those really aren't a big factor. The quizzes, they will matter. Again, so you should have taken all the quizzes. Can you take a quiz now? No, you can't. Again, the quizzes have a window. If you miss the window, oh well, right? Now, again, some of you have missed the window for legitimate reasons. That's something else, right? So if you were hospitalized, something like that, that's something else. But for some of you that I never heard from, you know, no communication with me whatsoever, didn't take a quiz, then you just didn't take a quiz, okay? Yeah, read the question. Right? I think you have plenty of time. And then we'll go from there. Any other questions? Okay. So if you want to leave, you may leave. A few people wanted to have a discussion about what my feelings were and things about going back to BU. If you want to have that discussion, we can talk about that for a few minutes, and then we'll go from there. So thank you all. I will be on campus in the fall. I will see a bunch of you in 222. Woohoo! There you go. So you guys will be my stars. Again, I'm grateful that I've looked at my class list, and a lot of the class is going to be people that had me before. So that's great, because that always is good, because you kind of my quirkiness already and know what I'm doing. So it's fun. So looking forward to it. So I think again, it's going to be on in person. It's going to be a little interesting, a little different, but we'll figure out a way to make it work. And for those of you that are taking me 222, you're going to get a poll probably. We're going to get a poll that's going to ask you to tell me whether or not I'm 100% remote. No, I am going to be there for class, because I've got to put together. My classes are big, so I need to assess how many people are actually coming and how many people are not, because it's for me to decide how I'm going to do the rotations, because not everybody's going to be able to go on the same day. So I need to know how many people are actually going to be coming or not coming. And I also want to know, if you're not coming, what your time zone is, because I want to make sure that I offer office hours and the TA has office hours at times when we can basically accommodate everybody, right? So it's good. All right. So thank you, everyone. Good luck on your tests. Have a great day. Good luck with everything else. Enjoy the rest of the summer. Some of you will be going on and not returning to BU. That you were here for the summer. That's great. Nice meeting you, and best of luck. Right. All right. So long. If you want to talk about BU, stay on. Otherwise, you can leave.